Hello everyone, this is the chapters that we'll be dealing with. We're gonna first deal with the exponents in our mathematics chapter. The first thing we must do, we must know the definition of an exponent. An exponent are convenient ways of writing a number that multiplying itself many times. For example, if we say 2 times 2 times 2 times 2 times 2, that's a long way to write a number. But an exponent is the way that we say 2 to the power 5. So that's a definition of an exponent. It is a convenient or an easy way to write a number that multiplies itself many times. As for example, which is writing 3 times 3 times 3 times 3. So let's go to the expression. A there is the base, P is the exponent or the index. The whole thing A to the power P is called the power. So sometimes you can say P is the exponent or a power because A is the base and P is the exponent. Okay, now we know how to express our exponent equation. With the equation, we know that we have a base, we have an exponent, and we have a power. So now we're gonna go to the laws of the exponent. The first one is when you multiply the exponents with the same base, what you do, you take the same base and add the exponents. There it's n plus m, so it's a one base and add the exponent. There is the example where you have 2 to the power 3 and 2 to the power 5. You take the one base and add the exponents and get 2 to the power 8. And then the second law is the law of division, dividing the exponent with the same base. So you take one base when you are dividing and you subtract the exponents. You take one base and you subtract the exponents. The example, you are having 3 to the power 4 divided by 3 to the power 1. So there you take 3, same base, and you subtract the exponents, 4 minus 1. And then the final answer is 3 to the power 3. The third law is the law of to the power 0. Any number that having a power that is 0, the answer is 1. You can take 100 to the power 0, it will give you 1. 5 to the power 0 is 1. And then if 0 is the base, any number that is going to be the exponent of 0, it will give 0. You can multiply 0 by 0 100 times, it will give you 0. And then 0 to the power 0 is undefined. 0 to the power 0 is undefined. And then the next law is when the exponent now is negative. We can write that as 1 over a, which is our base, to the power n. And then here our next law is when now we are having bases that are dividing and then they are to the power of a negative number. So if the exponent is negative, then what you do, you rearrange the one denominator iya numerator, le numerator iya denominator, and then your n is going to be positive. And then the last law is when the base now, a to the power m, is having a exponent of n. So the exponent will multiply each other, but the base will be the same. Those are the laws of exponents. And then the laws are used when we are simplifying. And we're going to take a simple example. And then there are steps to follow when you are multiplying or dividing powers. First, you write each base as the product of its prime factor. It is important to know the prime numbers. What are prime numbers? You simplify exponents where applicable. You add the exponents where same bases are multiplied. According to the laws, we said if it's multiplication, you add the exponents. If it's division, you subtract the exponents, and then you write the answer. Let's take an example. Simplify the following. It is 2n plus 2 times 4 to the power n plus 1 divided by 8n minus 1. And this question paper was taken from 20. Okay, let's rewrite the question. So it's 2 to the power n plus 2 times 4 to the power n plus 1, all divided by, it's all divided by, we said it's 8 n minus to the n minus 1. It's 8 exponent n minus 1. So the first thing, we must write every number to have the same base. So what you must do is to have the same base. So 4 can be written as 2. Okay, first of all, you can use your calculator to find the prime numbers. We said we must make, okay, let's just simplify it as each number here must have a same base. So to get what is the prime number of 4, you can use your calculator. You just press 4. After pressing 4, you say answer, and then you press shift, and then there is that button with that degree and something like a comma, but on top it's return fact. So it's 4, answer, shift, and then you press fact. It will give you 2 to the power 2. That's how you do when you are making prime numbers, or when you are changing your numbers or making them to have the same base. Okay, so you do the same procedure, and then 8, it's going to give you 2 to the power 3, and then it's n minus 1. So now you can see that all your numbers are having the same base. So what do you do if you are multiplying numbers with the same base? Let's just first open the bracket. So we said 2 multiplied by n, and 2 is going to multiply that 1, like you are opening the bracket. So we're going to have 2 to the power 2n plus 2 all over. You open the bracket with denominator, you say 2 to the power 3 n, and then 3 times -1, it's -3. And then you are having all your numbers with the same base, and then the numerator, you have a multiplication, and then after that you are having a division. So what do you do if you are having multiplication? You take one base and add the exponents, and then you divide 2 to the power 3n minus 3. So now you are having two numbers that are having the same base, and then they are dividing itself. So if you are dividing, what do? Okay, you're on the top side, what I did is 2, it's n plus 2, which was added with 2n plus 2. And then when you are dividing, you take one base and then you subtract what? The exponents. So when you subtract the exponents, so n plus 2 plus 2n plus 2 with the top, the numerator. So it's going to give you 3n plus 4 when you add it. And then that's the final answer. You just simplify everything. 3 from the top is going to subtract 3 from the bottom, and then 4 and 3 are the remaining. Then so your final answer should be 2 to the power 7. Your final answer, let me just verify, because if you follow our steps, yes. The next question, that's the second example that we are going to do. 64 to the power n times 16 to the power n minus 1 divided by 256 to the power n plus 2. It was taken from November 2015, paper 1 of grade 11. So let's try and simplify and follow the same steps that we did on question 1. So we know how to make prime numbers. It's the number, answer, shift, and then you press fact. Okay, let's rewrite the question. Try to make it large and visible. Okay, let's go to example 2. 64 to the power n times 16 to the power n minus 1, all divided by 256 to the power n plus 2. So we first make prime number zethu by pressing our calculators, and siyazi uba siyipressa njani. So 64 is 2 to the power 6 into the power n, and then 16 is 2 to the power 4 times n minus 1 all over by 256 is 2 to the power, what do you get when you press your calculator? It's 2, on my calculator it's reading, what do you get? 2 to the power 8 and then close bracket. So the second step, you open the brackets. What you do, you multiply the powers. 6 multiplied by n, it's 2 to the power 6n multiplied by 2, and then 4 multiplied by n, it's 4n minus 4. When you say 4 minus 1, it's minus 4, all over by, it's 2 to the power 8 on the denominator, multiply by, and then it's going to give you 16, and then everything have the same base. And then what do you do when you're multiplying the numbers with the same base? You take one base and then you add the exponents. That's what you do from our first law. You take one base and then 6n plus 4n minus 4, And then on the denominator, you just rewrite everything. And then now you are having numbers with the same base, and then they are dividing itself. So what is the law of exponent tell you is take one base and then you subtract the exponents. And then when you subtract the exponents, it's 4 minus 8. Okay, from the top, it's 6 plus 4, which gave us 10 minus 4. And then everything on the bottom side is still the same. So we are dividing. So it's one base and then subtract the exponents. We subtract the exponents. And then 10n minus 8n, that's 2n. And then negative 4 minus 16, that's negative 20. And then that's the final answer. Yeah. Is everything clear? From simplifying the exponents, getting our prime numbers. That is so simple when you have the knowledge of the laws of the exponents. So you must know the laws of the exponents. So let's do the third question. The third example, it's 81 to the power k times 27. Okay, let's just do it visible. So we have 81 to the power k, which is multiplied by 27 to the power negative k, and then it's negative k plus 1, and then it's times 9 to the power k minus 3. That's our numerator, and then divided by, and then our denominator, we are having a bracket which is 1 over 3 to the power of negative 2k, which is multiplied by 9 to the power negative k plus 1. So let's try to simplify the question. So the first step, make our prime numbers. Try to make everything that we have in the same base. So 81 is 3 to the power 4, and then bracket to the power k, and then 27 is 3 to the power 3, brackets to the power negative k plus 1, and then 9 is 3 to the power 2k minus 3. That's the numerator. Everything is in terms of 3 according to the base. And then 1 over 3, we can know that we can write it as 3 to the power negative 1. 1 over 3 is the same thing as 3 to the power negative 1 raised to negative 2k. And then we go to the last number, and then 9 is 3 to the power negative 2 to the power negative k plus 1. So now the next step, we open the bracket. 4 to the power k is 4k, and then multiply by 3 to the power negative k, it's 3 to the power negative 3k, and then 3 times 1 is 3, so it's plus 1 plus 3, I mean. And then you go to the last number, it's 2 times k, which is 2k. 2 times negative 3, it's negative 6. Done with the numerator, and then our division sign on the denominator, it's 3 to the power, okay, it's negative 1 times negative 2, it's positive 2. And then when you say 2 times negative k, it's negative 2k. And then 2 times 1, it's positive 2. Then we go to the numerator. We saw that we see that in the numerator we're having three numbers with the same base, and then they are multiplying themselves. So what we're gonna do, we take the same base. If the numbers are multiplying, we take one base and then you add the exponents. 4k plus negative 3k plus 3 plus 2k minus 6. And then on the denominator, you do the same thing. You take one base and then you add the exponents. So it's gonna 3 into the power 2k plus a negative 2k plus 2. So it's going to be 3 to the power 2k minus 2k plus 2. Okay, and then let's try to simplify variables zethu, and then sizokwazi to go to the division. So 4k minus 3k, that's 1k, and then plus that 2k is 3k, and then 3 minus 6 is negative 3. On the denominator, 2k and 2k cancel, and then 3 to the power 2. So you are having numbers with the same denominator, same base, and then they are dividing themselves. So take one base and subtract the exponents. So it's 3k minus 3 minus 2. So that's 3k minus 5. That is your final answer. So for now, you should be clear and